Good morning. My name is Jennifer Michalek, and I am the math consultant for the State of Connecticut Department of Education. Today I will be conducting a webinar on how to link curriculum, instruction, and assessment in mathematics education. By the end of today's presentation, you will know the following items. You will understand the structure of the Smarter Balanced Assessment. You will understand what the Smarter Balanced Assessment measures. And most importantly, how the Smarter Balanced Assessment links to curriculum and instruction. The first thing to understand is what the Smarter Balanced Assessment is. The Smarter Balanced Assessment consists of two components. The first component is the Computer Adaptive Test, referred to as the CAT portion of the test, while the second part is called the Performance Task, or the PT. The CAT portion of the test is the adaptive feature of the Smarter Balanced Assessment. It allows students to have more engaging questions from the real world. Because this is taken on a computer, it's more efficient for students than the typical paper and pencil test. And it also allows more flexibility and accessibility. There are a variety of accessibility features that are available to all students who take the Smarter Balanced Assessment, as well as additional features that are available to students with special needs. This accessibility gives access to helpful tools and resources while the students are taking the assessment, and the CAT portion of the test contains anywhere from 27 to 34 items. The performance task is still being given in mathematics on the Smarter Balanced Assessment. This requires students to answer a set of complex questions centered around a common theme. On the performance task, students have to take information from a variety of mathematical areas and incorporate them into one longer problem. Because of this, it really measures the complexity of understanding that the students have. Typically, a performance task contains 4 to 6 items. While the state of Connecticut stands firm that we should not be teaching to a test, we do need to be aware that we prepare students for the test. One way to prepare students for this assessment is to take a look at the various item types that the students will see on the assessment. And when appropriate, incorporate similar item types into daily instruction. On the Smarter Balanced Assessment for mathematics, students will see the typical multiple choice single correct response. This is no different than the multiple choice that students were used to on the mastery test. What is different with multiple choice is there are some items on the Smarter Balanced Assessment that are a multiple correct response, where students have to ask which of the following are correct or incorrect, and multiple answers should be selected. That's a really new type of item type for students and one that some struggle with. There are matching tables where they will have to click true or false or yes or no, and they have to click that for every item in the table. There is a short text feature. That type of question requires students to type in their answer. There is a drag and drop. The drag and drop feature requires that students have some understanding of how to utilize the mouse to be able to click and bring the appropriate answer into a table. There is also a hotspot, a table fill-in, graphing, and entering an equation. As you can see, the Smarter Balanced Assessment provides many additional types of test items as opposed to the mastery test, which was limited to multiple choice, grid-in, and constructed response. So what does the Smarter Balanced Assessment measure? If we're going to adequately prepare students, we need to understand what is being measured by that assessment so that it can inform our instruction. In order to understand what is being measured on the Smarter Balanced assessment, you want to make sure that you take a look at the blueprint. The blueprint that is currently on the screen is an overview of the 4 claims. This one happens to be for grades 3 through 5. There is another overarching blueprint that is available for grades 6 through 8. Let's take a moment to take a look at that blueprint. If you go to the Smarter Balanced site, you can find the summative test blueprint. And we are looking at the summative assessment blueprint for mathematics. There again, you see the 3-5 blueprint as we just saw, and you see the 6-8 blueprint. The important features of this blueprint is it will tell you how many CAT or computer adaptive items may be seen in that grade level for that claim, as well as how many questions of the performance task support that claim. Going deeper into the blueprint, you need to have a solid understanding of what a claim is. A claim is a summary statement about the knowledge and skills students are expected to demonstrate on the assessment related to a particular aspect of the standards. In Claim 1, we are looking at concepts and procedures. This measures the extent to which students can explain and apply mathematical concepts and interpret and carry out mathematical procedures with precision and fluency. We can think of Claim 1 as the nuts and bolts of the grade level. These are the skills at each grade level that are most important. When we move on to the remaining claims, it looks a little bit different. Claim 2 is about problem solving. That measures the extent to which students can solve a range of complex, well-posed problems in pure and applied mathematics by making productive use of knowledge and problem-solving strategies. One thing that's important to keep in mind is that when we're referring to problem solving, we're really talking about complex problems. Just by giving a student a word problem is not enough to know that they have problem-solving skills. There are several word problems that could be considered Claim 1, concepts and procedures, because the complexity of the problem is not as deep. Claim 3 is communicating reasoning, which measures the extent to which students can clearly and precisely construct viable arguments to support their own reasoning and critique the reasoning of others. And finally, Claim 4 is modeling and data analysis. That measures the extent to which students can analyze complex, real-world scenarios and can construct and use mathematical models to interpret and solve problems. As you might imagine, there's an overlap between Claims 2 and 4. It's very difficult to delineate out specific questions that might be problem solving versus modeling. In part to that reason, Claims 2 and 4 are reported as a single score. The blueprint contains more information than just information about the claims. The blueprints are expanded to show specific assessment targets related to those claims. We're going to take a look now at targets because that can be what really drives your instruction. Each claim has a set of assessment targets that give more detail about what is being assessed. Claim 1, the assessment targets are drawn specifically from the grade level cluster headings. So these are not a secret. You can look either at the blueprint or at the standards and see exactly what Claim 1 assessment targets are. Claims 2, 3, and 4 are drawn from the Connecticut Core Standards for Mathematical Practice. The Standards for Math Practice is another shift that these standards require, and they are in fact assessed on this assessment. So let's take a look at the Claim 1 targets. Claim 1 targets, because they are drawn from the cluster level headings, change based upon the grade level being assessed. In this example, we can see that a grade 4 cluster heading for number and operations fractions is to extend understanding of fraction equivalence and ordering. That exact language is Claim 1 Target F for grade 4. This holds true in grade 8 as well. If we look under the cluster heading of geometry, there is a heading that says, understand and apply the Pythagorean theorem. If you go into the blueprints and take a look at Target H for Claim 1 in grade 8, you will see the exact same language. Claims 2, 3, and 4 do not change based upon the grade level being assessed. These targets remain consistent. And the target language for Claims 2, 3, and 4 are drawn directly for the math practice language. In order to illustrate that point, let's take a look at Claim 3, Target D, which is to use the technique of breaking an argument into cases, and Claim 4, Target E, analyze the adequacy and make improvements to an existing model or develop a mathematical model of a real phenomena. If we cross-reference this with the math practice language, if we take a look at math practice 3, within the language of that practice, there is a statement that said they are able to analyze situations by breaking them into cases and recognize and use counterexamples. Comparing this to Claim 3 Target D, you can see that connection between the target language and the practice standard. The same holds true for Math Practice 4. In Math Practice 4, there is a statement that says they routinely interpret their mathematical results in the context of the situation and reflect on whether the results make sense, possibly improving the model if it has not served its purpose. Again, this relates directly to Target E of Claim 4. So understanding the target language and their connection to the practices helps remind us how important incorporating the math practices into daily instruction is. The Smarter Balanced assessment is one assessment given in a particular moment in time. What we want to get out of these assessments is understanding how it can drive our curriculum and instruction, which is a continuous and evolving process throughout the year. The first thing that you need to realize is that the assessment itself speaks to the progression of the topics of the Connecticut core standards. For instance, if we look at grade 6 under ratios and proportions, Target A says, understand ratio concepts and use ratio reasoning to solve problems. Under that same content heading, ratio and proportions, in grade 7, the target language changes to analyze proportional relationships and use them to solve real-world and mathematical problems. As is clearly evident, understanding something versus analyzing something requires a different skill set. Ratio and proportions are first introduced to students in grade 6, and then in grade 7, they expand on that understanding. Oregon has put together an expandable blueprint that has taken information from various Smarter Balanced documents. This information is all in one location, and these blueprints can help inform your instruction. These blueprints include a description of the target, as well as the evidence of what will be required of the student for that target. Let's take a look at the resource so you can see it. On this link, if you scroll down your page, you get to expandable blueprints. Let's click on grade 5, and a Word document will open up. If you look at this document, you can see the claim, and then it will break down the content category by priority cluster or supporting cluster. This is not to be confused with standards that should be taught and standards that would be nice to teach. Whether they are priority or supporting, all standards of the Connecticut Core Standards need to be taught in that grade level. The next column talks specifically to the targets. And if you look, you see a target description, evidence that requires, and the range of the achievement level descriptors. And by clicking on, you can expand those to get further information about the topic. The Smarter Balanced Assessment is built on depth of knowledge, and it's important for us to understand what DOK is, because the DOK is identified for each target. By understanding the level of complexity required of that target, that can help inform our instruction. So let's take a minute to review what depth of knowledge is all about. Depth of knowledge has to do with complexity. This is derived first at a DOK level 1. That is your recall and reproduction. Those are your basic tasks that are required. As we move up in DOK level, we move up in complexity. A DOK level 2 is basic application of skills and concepts. It requires the use of information, conceptual knowledge, the selection of appropriate procedures, oftentimes problems that require 2 or more steps with making decisions along the way, or organizing and displaying data, or interpreting and using the data. DOK 3 is about strategic thinking. This requires reasoning, develop a plan or sequence of steps to approach a problem. It requires justification, complex, they're often non-routine, and most interesting, there's often more than one possible solution. The final DOK level is DOK level 4, which is extended thinking. There are a limited number of DOK 4 items on the Smarter Balanced Assessment, and the reason for that is these are investigation or applications to the real world that oftentimes requires research, problem solving, multiple conditions, and a variety of other disciplines in order to solve the problem. As you can imagine, this requires a great deal of time and effort, often not available on a test that is given like the Smarter Balanced Assessment. So you need to remember that DOK is about complexity, not difficulty. It is the outcome that determines the DOK level. What is it that the students have to produce, and what mental processing must occur in order for that to happen? Unlike Bloom's taxonomy, which relied upon the verb to determine its level of difficulty, DOK is really what comes after the verb. To illustrate this point, we can take a look at this example. Describe the properties of a parallelogram. Describe how ratio and rates are alike and different. And describe the most significant component of a linear graph. All 3 of these statements use the initial verb describe. However, the complexity level that's required of these statements varies. In the first one, describe the properties of a parallelogram. That is primarily a recall of information. There are set properties every parallelogram has. That is something students can commit to memory and recall those facts. In the second example, describe how ratios and rates are alike and different, requires a comparison and contraction. Compare and contrast the two items. This requires a higher level of thinking because students need to first think about what is similar between ratios and rates, and then use a different frame of reference to identify what is different. Lastly, describe the most significant component of a linear graph is the most complex of these three. There is a judgment that needs to be made by the student. They would need to be able to back that up and justify that judgment based upon their information and create an argument to support that. The cognitive rigor matrix integrates Webb's depth of knowledge with Bloom's taxonomy that we are most familiar with. When we are looking at putting this into practice, we really are looking at trying to go to the lower right-hand quadrant of the graph for our most complex tasks. That doesn't mean that there's not a place for DOK Level 1 problems in your tasks. You need to make sure that you have a good balance. You can see from this chart, which is also available by clicking the link, that you cannot have a Bloom's taxonomy of remember that is, let's say, a DOK Level 3. Remember innately is DOK Level 1 because it is recall and reproduction. Similarly, you cannot evaluate something that is a DOK Level 1. At the minimum, that would be a DOK Level 3. Now that you have had some experience with taking a look at what the different DOK levels are, we are going to take a look at a couple of examples to see if you can identify the DOK level being assessed. Very often, we get into the habit of thinking multiple choice must be a DOK Level 1, and a word problem must be a DOK Level 3 or 4. This is inaccurate, and we need to make sure that we clearly look at our problems and identify the DOK levels. Incorporating all levels of DOK in classroom instruction and assessment will help students be better prepared for the cognitive demands of the Smarter Balanced assessment. Let's take a look at this grade 8 example. The question simply says, in which set are the numbers equivalent? And there are 4 choices. Take a moment and think about what DOK level you think this question falls under. This example is DOK Level 2 because there are a number of different concepts and procedures that can be used for this problem rather than one obvious simple one. Not only must they identify different representations, such as fractions, percents, and decimals, they must also manipulate and compare those different representations. This is our second example. It says Bill lives on the side of the street with even numbered addresses. Which addresses below would be found on Bill's side of the street? Although this problem is set in the context of a word problem, this is still only a DOK Level 1 because students only need to be able to recognize even numbers. That is a recall type problem. Here is our final example for multiple choice DOK levels. It says, which of the following is not true for any value of X? This example is an example of DOK Level 3. This item requires generalizations, reasoning, and hypothesis testing. Even though these are all multiple choice items, the complexity of the problem and the level of cognitive demand that is needed in order to solve the problem is varied. This same idea holds true for open-ended questions. An open-ended question does not necessarily mean that it will be at a higher DOK level. To demonstrate this point, look at the questions on the slide. The first question says, from any vertex of a four-sided polygon, one diagonal can be drawn. From any vertex of a four-sided polygon, one diagonal can be drawn. There's clearly an error with this question, and I apologize for that. Ultimately, the question will ask for how many diagonals can be drawn from any vertex of a 20-sided polygon. This particular question should have had a pattern going in the dialogue before getting to the question. The second question says, think carefully about the following question. Write a complete answer. You may use drawings, words, and numbers to explain your answer. Be sure to show all of your work. Laura wanted to enter the number 8375 into her calculator. By mistake, she entered the number 8275. Without clearing the calculator, how could she correct her mistake? And then the question was restated. Without clearing her calculator, how could she correct her mistake in another way? These two problems, although both word problems, are at different DOK levels. The first one is a DOK level 1 because had the pattern been established, it was a simple pattern that could then be applied to a 20-sided polygon. It was an easily recognizable pattern that didn't require much processing. However, the second open-ended question has more than one possible answers and multiple approaches to the problem. The student needs to make strategic decisions about how to proceed. That is more complex than simply applying a set of procedures or skills. So what does DOK mean for your own classroom assessment? By incorporating the various DOK levels into your own assessments, students will understand the varying level of complexity needed in order to meet the cognitive demands of the Smarter Balanced assessment. Some guidance on how to do this can be seen on this slide. When we are looking at formative assessment, we should be looking at problems that are levels 1 and 2. Formative assessment is varied, it's ongoing, it's an on-the-spot assessment of what students know and do not know. When we start to move up the chain and get into summative classroom assessments, in most cases, we are looking at levels DOK 2 and 3. These can include standardized assessments or end-of-unit assessments. Finally, we should be incorporating performance-based assessments in our classrooms, and those are typically of levels 3 and 4. They should be complex, aligned to the Connecticut core standards, and very often are some sort of inquiry-based project. You want to keep in mind that DOK is a tool to promote student achievement, and it is a scale of cognitive demand. We do not want to see any questions that are solely at one DOK level on an entire assessment. We also do not want to see just high DOK levels on an assessment. Using a balance and range of DOK levels will give you the most bang for your buck. Remember that DOK level is determined by the item or the standard that it is associated with, not the student's ability. That's important to remember because very often we start to give our struggling students only DOK level 1 questions. That inadequately prepares them for the assessment because although they may be struggling, they need to understand the complexity that may be needed to achieve a certain standard. Again, DOK is determined by the context of the problem, not the verb that is being used. And finally, a DOK1 and a DOK1 does not always equal a DOK2. So again, if you were to give your students several DOK level 1s, it's unfair to make the assumption that, well, since they can do that, they would be able to do a problem with higher complexity. You need to provide them with items that are of that higher complexity in order to make that determination. The last part of this webinar is going to discuss how does the Smarter Balanced Assessment connect with interim assessments. The interim assessments also has two components. There's an interim comprehensive assessment, and there is the interim assessment blocks. The first one that I will speak to is the interim comprehensive assessment. This uses the same blueprints that we saw earlier in this presentation and assesses the same standards. It also includes the same item types and formats and performance tasks. However, it is not recommended that you give the interim comprehensive assessment without a lot of thought given. And the reason for that is the interim comprehensive assessment takes the same amount of time to administer as the summative assessment takes. That means you need to outweigh the benefits of giving the assessment with the loss of instructional time that will occur. In mathematics, there are also the interim assessment blocks. These blocks focus on assessing a finer grained level of instruction. They were developed to be used as part of a unit of study. Currently, they are available as fixed form tests, meaning they're not adaptive. The reason that's important to understand is if you were to give this assessment multiple times, the students would be seeing the same questions. Clearly, overexposure to test items can alter the results. Similar to the ICA, the blocks include the same types of items and formats of items that you would see on the Smarter Balanced Assessment. Currently, each grade level has 3 blocks and a performance task available. As there are more test items developed, we are hoping that you will see more blocks available. The non-performance task blocks are completely machine scored, meaning that if you administer these blocks to your students, you will be able to get scoring pretty quickly. In addition, there is an item analysis feature that is currently available, although we are working to even improve that. Just like on the comprehensive assessment, there is a blueprint. There is a blueprint that goes for each of the blocks in the Smarter Balanced Interim Assessment System. These blueprints provide another way for you to have vertical meetings in order to make sure that your instruction and curriculum is meeting the needs of the standards. As an example, if we look at fractions, there is a fractions block in grade 3, in grade 4, and in grade 5. Clearly, this is not the same block, and it is not the same set of standards being addressed in the block. If we take a look further, you will see that in grade 3, there are 12 Claim 1 items. There are no Claim 2 or 4 items, and there is one Claim 3 item. By the time you make it to grade 5, there are 11 Claim 1 items, 2 Claim 2 and 4 items, and 2 Claim 3 items. As you can see, in grade 3 is when fractions are first introduced, which is why the focus is on Claim 1 with 12 items. That is your nuts and bolts claim. However, by the time you reach grade 5, they are expecting that not only do you know about fractions, but you also understand how they can be applied and used in problems. Therefore, there is an opportunity to assess that with Claim 2, 3, and 4 items. It's important to remember when you're using interims, or any assessment for that matter, that you have clarity regarding the purpose of the assessment and the uses of the assessment data before using it. Anytime we give students an assessment, we are taking away from direct instructional time. We need to make sure that the purpose of that assessment is important enough to do this. When we're talking about possible purposes for the interim assessment, you may see things like curriculum. You may want to give the interim assessment as a way to see how is our curriculum aligned. We know that many districts have gone through curriculum revision processes in order to align to the Connecticut core standards. However, now that we know more about the standards and have begun to implement that curriculum, several districts are going back to ensure that that alignment does in fact occur. You may also want to use the interims in order to take a peek at your instruction. Are you incorporating all DOK levels in your instruction? Does your instruction meet the standard being assessed? You may also want to use an interim as a pre and post to evaluate student learning. Another possible purpose of the interim is simply item type familiarity. There are certain types of items that on a traditional pen and pencil test, we are unable to do. For instance, drag and drop. Some students may have difficulty with this type of item simply because they're not exposed to it on a regular basis. By giving an interim that may contain that type of item, we are exposing them to that prior to the administration of the summative assessment. Finally, you may want to use your interim assessments as professional development. By taking a look particularly at the performance task and having various teachers score the open-ended performance task items, there can be really good professional learning community conversations that can come out of that work. The interims have grade flexibility. You can use tests from any grade. Again, what you choose to use has to be directly related to the purpose of its use. If you have questions about any of the information that I have presented during today's webinar, please feel free to contact me at my email or at my phone number. Thank you for your time, and I wish you well.